Hi, my name is Dr. Matthew Joby, and I've been teaching the history and modern viewpoints of psychology for Rutgers University at Newark since 2004. This has been my principal area of teaching and studying over the past 11 years, and I'm making this series of lectures available for two reasons. Firstly, there are no history of psychology lectures available online. We have a lot of introduction to psychology and perception and neuroscience and personality theories and developmental theory courses available for free online to students, but we don't have any history and systems of psychology courses online. So I think that this is fulfilling a need. The second reason that I'm offering this course online for students is because I have come to understand over the past decade that many undergraduate institutions do not require the history and systems of psychology for their psychology majors. At Rutgers University Newark, we do require this course for all undergraduate students. And of course, I believe this is an important course for students to take. It may be the most important course that a student will take in psychology. And the reason I say this is because if we don't know, if we are historically shallow, if we don't know where we've come from and where people who have come before us have been, we have a very non-contextual understanding of where we're at and where we're going. History is a very important part of understanding what we do as researchers and as thinkers and intellectuals, as therapists. We have to understand the historical context, and we can't be historically shallow, historically ignorant. So these are very important aspects, I think, for any well-rounded psychologist to take seriously. That being said, we have a series of textbooks that we could choose from for a course like this. And of course, over the past 11 years, I've used a number of different textbooks for this course. I have some favorites. I have some that I don't have a very high opinion of, but there is one that was recently published that really stands out, and this is the one that I'm going to encourage you all to get and to use for this course, and it's called A Critical History and Philosophy of Psychology. And as you see, this is not only the history of psychology, it's the philosophy of psychology. That's not what makes it different from other history of psych textbooks. What makes this book different is the critical history. This book really resonates with my teaching style, which is to take an externalist view, not an internalist view of the history of the science of psychology. So, for instance, an internalist history, as Thomas Leahy describes in one of his articles in the APA published book, Evolving Perspectives on the History of Psychology, Leahy describes what he calls internalist views of history. This would be like a cheerleading. This would be when a psychologist who specializes in research, perception, or developmental research, or some other sort of research, teaches the history of psychology as an insider, someone who tends to maybe even be a cheerleader for the discipline. We take a critical history of psychology. In other words, we don't hold back in pointing out not only the accomplishments and the successes of the field of psychology, but we're also very critical of it. We point out some of the negative points of it, all of the negative points that we can manage at least, and we take a real critical look at this. This is informed by the Frankfurt School of Critical Theory, and in so doing, this is how we distinguish ourselves from other courses in the history of psychology. So I really recommend, if you're getting one book, this is the book to get. There are some others that I would recommend. Definitely one that's out of print, Robert C. Bolles, Bolles, A History of Psychology, or The Story of Psychology, I believe. You can find that online. As I said, it's most recently out of print as far as I can tell. Also, the Hergen, Hahn, and Henley, An Introduction to the History of Psychology, is another excellent book. A book that, to supplement your studies, is Mary Henley, Henle, Mary Henley's 1879 and All That, former professor of the history of psychology at the New School. It's an excellent book. And Yeah, I think the Thomas Leahy book is a great book. The others I've read have not captured they haven't resonated with me as these other books have. So this is where we'll go from our starting point. The supplementary reading would be great if you can do it. And I'm going to closely follow a critical history and philosophy of psychology in these lectures. So here is how we start this course typically. We have three major issues that we're going to discuss. Firstly, we want to make a distinction between history and histories. We take the approach that there is not a history of psychology, there are histories of psychology. Every book we have a different, every book on the topic will present a slightly different story, more than slightly, and every professor who presents this material will give a different story. This is how histories are performed. So instead of discussing a history of psychology in kind of an authoritative way, we're going to discuss different histories of psychology. This will be one of many histories that you will encounter. So I would encourage you to read as many different books as you can on the topic and hear the different histories. This will give you a better rounded understanding of the context of the history. We also look at psychologies rather than psychology. We have at least 7 different schools of thought in psychology. We are not a unified discipline with those 7 schools of thought. I'm speaking of biological psychology. I'm speaking of cognitive psychology, evolutionary psychology, behavioral psychology, the sociocultural psychologists. We're looking at humanism, what we also call existential phenomenological psychology, and psychodynamic psychology. These are the 7 major schools of thought in psychology, and each of those have a different definition of psychology and different research methods. So, as we know, about 80% of the psychology field calls themselves cognitive psychologists. But we aren't going to privilege cognitive psychology or even privilege the definition of cognitive psychology. It's one of 7. And this history will be taking a look at how cognitive psychology, how that became a dominant paradigm. And that's part of the story. And also realizing that it is a temporary paradigm and the definition of psychology will switch yet again. The third thing that we're going to look at is a big topic, and it's systems of knowledge. This is part of postmodern theory, and structures or systems of knowledge will look at how we can discuss truths within contexts. And I'm going to unpack that shortly. So this comes directly from the article I mentioned earlier, the Thomas Leahy article in the Evolving Perspectives on the History of Psychology. And this is what we have, the 6 sins of history. And we're just going to go through this because it begins to show us the historiography, how we do history. We're doing a critical history of psychology. We talk about Whig histories. Whig histories are histories that look at the past as this inevitable series of marching progress to the moment of the moment of now, this ultimate superior moment, and a Whig history would look back on a more naive past and view the present as the great pinnacle of psychological wisdom. Of course, this is very much a fallacy. There are things in psychology that are much better and much more insightful than some of the psychologies of the past history. However, there are moments in history and concepts in history, some of which have fallen out of favor and fallen out of the spotlight, that were actually much more sophisticated and much more intelligent and useful than some of the theories that are popular today. So we want to be aware of doing Whig history. We're not going to present psychology of today as the greatest psychology and the smartest psychology, or it's in its best development. We look at the context of each moment of history, and we take today on its own terms, and we'll critically examine its strengths and its weaknesses. Presentist histories. And presentist histories are concerned with with contextualizing the past based on present criteria. So when we look back at time periods of history, we're going to see issues that could be discussed as being racist, we could be sexist, any type of attitudes that are current contemporary attitudes that we are inflicting on past context is a presentist history. For example, one of the most famous presentist's interpretation is Freud's research with cocaine, and his cocaine episode, and taking a presentist view of Freud as some sort of illegal cocaine snorting fiend is something we're not going to do. This is a rather popular example for this. So presentist histories, we're going to take the historical event, the individual, on its own terms and not merely judge it as if standing as it's existing in the present. So that's a presentist history. Internalist history, I've already described this to. An internalist history is kind of like a cheerleading from within. It's not a critical history. This often happens when you have someone who is teaching the history of psychology, and it's not their main area of study, but they're stuck teaching it for the semester. It's their turn to do it, so they step out of their lab or their main area of research and teach the history of psychology almost as a way to show how great the field is to the students. We're not going to do this. We're not going to take an internalist history. We're going to take a critical history. And this is in the tradition of someone like Howard Zinn, who wrote A People's History of the United States. It was a critical history, not the history of what we call great man histories. So a great man history, next on our list, is the type of history that gives a story of a chronicle of great men. And of course, they literally are men, Western European men, who often appear in some of the textbooks, many of the textbooks. And we're not going to study history this way, as a succession of great men in a linear fashion. This is not the way history takes place. We are going to approach history with an awareness of how in a patriarchal structure, the story of men have been told, and how this has affected the influence, or at least the remembering and the historical record of women in the field. So we will not be doing great man histories. We're also going to be aware of what we described earlier, these two concepts, historically ignorant. So this means becoming aware of popular cliched misconceptions of past times, and we're also going to avoid being historically shallow. And this means that anything that's coming before that year 1879 is dismissed as out of date, where you can even carry this into a criticism of any research that maybe your professor tells you you're not allowed to cite research older than 5 years. This would be held in contempt by historians. This is demonstrating historical shallowness. Please do look into history and see what the story of your research interest is beyond 5 years. Beyond 5 years. Don't be historically shallow. So these are the 6 sins of history that we're going to be aware of, and this is what we call historiography, or the rules of how we do history. Here's a little quote from one of the famous historians. His book was used for many years. E.G. Boring, the experimental psychologist needs historical sophistication within his own sphere of expertness. Without such knowledge, he sees the present in distorted perspective. He mistakes old facts and old views for new, and he remains unable to evaluate the significance of new movements and methods. In this matter, I can hardly state my faith too strongly. A psychological sophistication that contains no component of historical orientation seems to me to be no sophistication at all. So these are some words about the history of psychology and why it's important to study history by E.G. Boring. Gordon Allport. We know Allport as the individual who developed trait theory and personalities. Gordon Allport says, our profession progresses in fits and starts, largely under the spur of fashion. We never seem to solve our problems or exhaust our concepts. We only grow tired of them. Fashions have their amusing and their serious sides. We can smile at the way bearded problems receive tonsorial transformation. Having tired of suggestibility, we adopt the new hairdo known as persuasibility. Modern ethnology excites us, and we are not troubled. But the recollection that a century ago John Stuart Mill staked down the term to designate the new science of human character, reinforcement appeals to us, but not the age-long debate over hedonism. The problem of freedom we brush aside in favor of choice points. We avoid the body-mind problem, but are in fashion when we speak about brain models. Old wine, we find, tastes better from new bottles. So with Gordon Allport, he's pointing out that we need to be aware of fads in psychology. And these fads, when we become aware of them, we notice that the concepts are often repeated throughout history, but the names are changed and the context is changed, and what he calls old wine in new bottles. A very interesting postmodern theorist, Paul Feyerabend, critic of science. He wrote a textbook called Against Method. He's an anarchist. He's an intellectual anarchist. He was from Austria. Paul Feyerabend says this: the history of science is full of theories which were pronounced dead, then resurrected, then pronounced dead again, only to celebrate another triumphant comeback. It makes sense to preserve faulty points of view for possible future use. The history of ideas, methods, and prejudices is an important part of the ongoing practice of science, and this practice can change in surprising ways. So why do we study the history of psychology? Well, we want to study the history of psychology to recognize fads and fashions in thought. And you could probably have noticed over the course of your few years as an undergraduate in psychology that there have been certain fads and fashions that come in and out, and we can identify these fads of thinking, these fashions of thinking. And it turns out that we can often notice that when a new idea comes along in psychology, there seems to be a tendency for many thinkers and psychologists to believe that this new thing is the panacea answer to problems. So we see this repeatedly. Most recently, genetics was the fad in research, and it took us some time to really identify that things weren't what we thought they might be with genetics. So this had its greatest influence in the early 2000s, then late 90s to the early 2000s, and then interest started turning elsewhere. So this is one example, the most recent example of fads and fashions. We had an evolutionary fashion and fad come into effect, where evolutionary psychology really gained a great deal of steam, and then something else came along, and so we want to be aware of these fads and fashions that happen throughout history, and be careful that we don't get caught up too much in them. We want to know our perspective is not the perspective. So if you're a cognitive psychologist and you think you're doing the psychology, we have to remind others that of the logical fallacy, no true Scotsman. This logical fallacy is that setting these sort of conversation stoppers does indeed stop the conversation. So if the psychoanalytic or psychodynamic psychologist who dismisses the other six schools of thought for their lack of depth or superficiality, psychodynamic psychology is not the perspective. Cognitive psychology is not the perspective. Behaviorism is not the perspective. So we want to know, we want to really understand through studying history and how maybe the perspective that we come from, the school of thought that we resonate with, how that came to be and how it fits in with the context of other perspectives. So this is really an endeavor against any sort of intellectual arrogance. So we want to look for a certain humility in our perspective. And you can have a school of thought that you identify with, but to think that your school of thought is the exclusive way of doing psychology is really not a very wise thing to do. We want to understand the trends and the tendencies and ideas. We want to avoid repeating errors of the past, wasting time, wasting resources. We want to expand our ideas beyond the cliches, beyond the whatever ever is contemporarily prominent. We want to look beyond that. And we want to understand how century-old questions lend humility to new problems. We notice when we look at these, the problems of today, that they really aren't new. They are maybe a recently manifested version of eternal problems. And of course, we want to take a critical attitude. We want to understand what it is that are the strengths and the weaknesses of our field, as well as our particular paradigm and the paradigm that others engage in. So let's turn now to this question: what is psychology? And who decides what is legitimate? So is biological psychology the psychology? Is social interaction and the unconscious and motivation, physiology, sensation, thinking, emotion, interaction, behavior, are these what aspects of this is the real is the right psychology, the real psychology? Well, of course, this is going to depend on which school of thought you are associated with. And this brings us to the concept of systems of knowledge. Now, I adopted this model, which originally came from American philosopher C.F. Peirce as a communications triangle, and this is adapted by a postmodern theorist named Jean-Francois Lyotard, who wrote a book for the Canadian government in around, I think it was around 1984, called The Postmodern Condition, an Assessment of Knowledge. And we use these systems of knowledge to illustrate each school of thought. So we have an addresser and addressee, that's a speaker and a listener. And whenever there's a conversation between two people, we have an unspoken referent. This is the thing that their conversation is referring to as the guideline of the conversation, of the reality. It's the thing that we don't necessarily talk about, but we both assume it's there. And each one of these referents has a code, and the code are the words that we use. So to make this a simple illustration, I'll give this. If we have two cognitive psychologists, the addresser is a cognitive psychologist, the addressee is a cognitive psychologist, the referent is the principles of cognitive psychology, the rules of the game of cognitive psychology. So, for example, the definition, the scientific study of behavior and mental processes. Both the addressor and the addressee assume the idea that human beings, psychology is a science, and that it studies behavior and mental processes. The code words are the words that we can use to identify the referent. So if you have individuals who are together talking about, say, long-term memory, short-term memory, information processing, this is computer language. We know, of course, that's cognitive psychology. Psychoanalysts and humanists don't talk about long-term memory and information processing. Psychoanalysts, you would see terms such as libido and Oedipal situation, perhaps, and maybe transference. These are code words for the referent of psychoanalysis. For humanism, we have existential issues and becoming, etc. So each one of these schools of thoughts is a referent. Now here's, with its specific language, a code. So when you're listening, as soon as we get our Introduction to Psychology textbook and we read the definition, the scientific study of behavior and mental processes, this is the code word for the referent of cognitive psychology. We know at that point that the author of that textbook is a cognitive psychologist. Now, here's the interesting thing, and this is what was described by philosopher Ludwig Wittgenstein as word games. When we talk about games, we're not talking about ha-ha fun. We're talking about rules that structure how knowledge is done, and each of these schools of thought have different rules. what's allowed in, what's allowed out, what's not permitted, what's allowed to be discussed, what's not taken seriously. Each of the 7 schools of thought have different rules about how psychology is done and what is appropriate to be studied. So the question is, what if we have an addresser and addressee from 2 different referents? This happens all the time in psychology. So maybe one addressee, maybe the addresser is coming from the psychodynamic perspective, and the addressee is coming from the biological perspective. Each have different reference and different codes. This would not be unlike, as Lyotard describes, people showing up to play a game and have a discourse, a conversation, and one showing up with a Monopoly board and the other showing up with a Scrabble board. And each of them are following the rules of their game as they feel it should be done. But they don't have the same referent. They have different code words, and ultimately the game breaks down. The conversation can't be had because they're operating in 2 different paradigms, 2 different systems of knowledge, 2 different schools of thought. So the question is, which one is better? Which one is which is the right one? And we don't ask this question. We look at each on their own terms, and we find that in some situations, certain schools of thought give us more effective information than other schools of thought. So there are things that psychoanalysts do better than any other psychology school of thought. And there are things that biological psychologists do much better than any other of the schools of thought. And there are certain things cognitive psychologists do well, humanists do well, existential phenomenologists do well, sociocultural folks do well, evolutionary psychologists do well. However, to say that one of these paradigms is better than the other is really something we want to avoid in this course. Since we're taking a critical look at this, we want to look at them each on their own terms and look at them each on their own strengths and weaknesses. We now look at the idea of a linear history versus a nonlinear history. So linear is kind of like the typical way things are taught in middle school, kind of a historical, political, patriotic history of marching on of time and towards progress. That's linear cause and effect history. History really doesn't function this way. This is an artificial structuring of history. History really functions more like a boiling pot of water, or like we see here, a ginger root, what's called a rhizome. So we take a rhizomatic nonlinear history that has no center. We see in this root structure of the rhizome, there is no center. Things develop simultaneously and affect one another in relationships, kind of like in a network, but it's not a cause and effect tree root kind of linear structure. There is no center here. Think of a boiling pot that's bubbling seemingly and chaotically. This is a rhizomatic, nonlinear way of looking at things. And this is the way we are going to look at history to some degree. Of course, a real rhizomatic history would be written by someone. If we look at the histories of science, like the archaeology of knowledge and madness and civilization and power of knowledge by the postmodern French philosopher Michel Foucault. These were nonlinear histories. Manuel de Landa, in his books, A Thousand Plateaus, by Guattari and Deleuze, these are schizophrenia and capitalism, etc. These are all nonlinear rhizomatic histories. The textbooks that typically appear for history of psychology tend to be linear, but we're going to make an attempt to keep in mind the rhizomatic, nonlinear history that is more accurate with how we experience it. This is an important concept coming from G.W.F. Hegel's book, The Philosophy of History. And Hegel was really, I think, what we could call the first critical historian. And he wrote a book called The Philosophy of History. And I'm just pulling it off my bookshelf here. G.W.F. Hegel wrote this book in 1857 is one of the earliest editions of the writing of the book. So we are looking here at a book that is very influential in our study and the way we're doing this. So we are going to look through this book, and you'll see, if you buy this book online, G.W.F. Hegel Lectures on the Philosophy of History, you'll see that he goes through doing his method of history. And this is what we refer to as the dialectic. And the dialectic is the conversation. And this is this is a little diagram that I made to describe the idea of the dialectic. This S should be over here on the I. It should be synthesis, not synthesis. But we have an idea, a thesis, let's say behaviorism. And then as the behaviorists are the dominant paradigm in doing psychology, we have an antithesis or an antithesis. And this would be some group of thinkers that are not in the majority. They don't have the power. They aren't hiring new faculty members. They aren't deciding who's getting funding for research. They're not the gatekeepers of the journals and the textbooks. These are the minority group of individuals, those who are marginalized but think differently than the main power structure individuals. So this is behaviorists back in the 1950s, and we had these computer science and linguistics and information processing and artificial intelligence people converging, doing this thing they started to call cognitive psychology, would be the antithesis or the negation of this thesis. And then what we have is a revolution. And what comes out of this revolution is a synthesis, something new. And we know what came out of this was something like cognitive psychology. We might even say cognitive behavioral psychology. And Hegel said that history progresses in fits and surges like this, of thesis, antithesis, and synthesis. He also referred to something called the Zeitgeist, the time spirit. And he was a German idealist, which we're going to get into in this course. But just to give you a sense of what an idealist is, German idealist, this doesn't mean that they're an idealist like looking for the good or like an optimist. An idealist is someone who believes that reality is a reciprocal relationship between the viewer and the viewed. So we don't do a subject-object split like science would do. We say that the object, that we participate in making reality happen, and without a perceiver, there is nothing to be perceived. This being said, the Zeitgeist is the time spirit. Zeit, time, spirit, ghost. The time ghost, the spirit of the times. This is an unmeasurable, unobservable kind of just sense of a certain milieu that exists in history. We can think of maybe the zeitgeist of the 60s. That may resonate with the current zeitgeist in the early 2000s of certain qualities in American politics and social movements and revolution, the Occupy movement, etc. It resembles the zeitgeist of the 60s in some way. So this zeitgeist history is something we want to be aware of. And Hegel says that we can understand these zeitgeists and movement towards what he called an absolute. But we'll get more into that later when we study Hegel in German idealism. But we want to be aware of this, of how Hegel's dialectic affects our study of history for an important reason that you'll see shortly. I like to take an intellectual history point of view. Intellectual history is a history of ideas. And that being said, I break history up into three periods. Pre-modern. Pre-modern is to about the 1600s CE. Then around 1600, 1650 to somewhere around World War I or World War II, we have the modern period. And then since World War I and World War II, we have something called the postmodern period. And then we are existing now in the postmodern period. Now, I want to be clear on this up front. There are historians who do not accept the idea of postmodernity. This is one of those debated areas by intellectuals. I happen to be an individual who teaches from this point of view, that we are in a period of postmodernity, postmodernism. And I'll explain what this means. So in Friedrich Nietzsche, who is also another great writer on how to do history, Nietzsche taught us that this pre-modern was a Dionysian period. Dionysian meaning based on very emotionally driven romanticism on sacred rites and mysteries and mysticism and this sort of thinking. Pre-modern, it was dominated by mythos, by mythology and narrative. In the 1600s, we had a transition, what we call the Enlightenment and the Scientific Revolution, and this ushered in a period of modernism, the belief that science, in other words, that this science as defined as logic and mathematics, could lead to ultimate big T truths. And this had displaced or replaced the narrative, the mythological narratives of religion and things of this nature. Postmodernity was a questioning of this modernism. After we have, of course, the dropping of atomic bombs on Japan, mechanized war, machine guns, chemical warfare, all these things, we came to realize that science, in other words, logic and mathematics and the scientific pursuits and technology were not necessarily good, but were tools that could be used for good or bad. And they didn't lead to big T truths. They led to little t truths, and the difference between a big T truth and a little t truth. In the pre-modern period, it was said that there could be big T truths that were supplied by religion. In modernism, there was big T truths, ultimate truths supplied by science, logic, and mathematics. And in postmodernity, we say there are no big T truths. There are only little t contextual truths. So you can have things that are true, but these truths are only contextually true within a system, like a gestalt. So this is the book, The Postmodern Condition by Jean-Francois Lyotard that we mentioned from the early 80s, and Lyotard describes this postmodern condition of knowledge. He talks about information rather than knowledge, and as we know from that systems of knowledge, information can be edited and reassembled into many different ways of knowledge. Just like a film, you can have film footage, and that film footage can be edited into an infinite amount of films. Well, in this way, information can be edited into and organized into many different knowledges. And this is a very postmodern kind of idea. So this is how intellectual history unfolds, and it is how we will be talking about history. So we turn now to this question, what is science? This is a very big question. This is a very big question. Here are some of the concepts that we discuss when we talk about science. Words like empirical and rationalism, scientific method, theory, hypothesis, correlational law, causal law, observation, measurement, causality, determinism, truth with a big T and truth with a little t. You see this and you know what this is now. Knowledge, information, paradigm, biological determinism, environmental determinism, reductionism, genetic fallacy, naturalistic fallacies. These are all aspects of this term science that we are going to explore together. So we'll take a look at these terms and become familiar with them. Well, I think the first thing to discuss is the word science. The etymology of the word science is scientia. It comes from a Latin word. And it has, according to which, depending on which etymology dictionary you look into, you'll find something as simple as the acquisition of knowledge, and the other is an organized system of knowledge. So scientia, in its original setting, really didn't refer to these terms that we understand it. Usually we think today, we hear the word science, and we understand these kind of words, Bunsen burners and white lab coats and cause and effect, maybe even fact and truth. We're going to find that this is there are some limitations in these points of view, and it's also an antiquated way of thinking about science. Well, recently antiquated, but the most ancient form of the word science is the acquisition of knowledge. We can think about science, scientia, if we look back to the German, the Prussian system of education, and we'll find that if you look at German university today, you'll have courses in department in religious sciences, the science of religion. This is a very interesting way to think about things. Well, in the German system, we had Geisteswissenschaften and Naturwissenschaften. Excuse my German pronunciation, but the Geisteswissenschaften was the the sciences of the ghost, of the spirit, and the Naturwissenschaften were the sciences of nature. And so literature and poetry, psychology, philosophy, history, all these things were Geisteswissenschaften, whereas physics and chemistry and biology were Naturwissenschaften. So we have these, we should remember that psychology branched off of philosophy, and that was part of what we today might call the humanities. So we have a distinction here of this word science, and when we use science to refer to scientific method or anything like this, we're using an Enlightenment tradition, a modernist view of what science is. But this is a contextual word. And as we'll see, words change meaning within context and within historical periods. There aren't definitions that remain constant. It's always a context. So I'd encourage you to get a good etymology dictionary app, or find the etymology online website, or buy yourself a thick etymology dictionary and keep it close by, and always consult the origins of words, and also consult historically what a word means. For example, the word science. We could also give this, we'll be giving this as an example when we talk about the word psychology, which comes from psyche. When I ask students often what is the first word that comes to mind, what does psyche mean, they say mind. And of course, this is a very Enlightenment scientific revolution definition. The word psyche, of course, comes from Psyche comes from Psyche and Eros, the myth of Psyche and Eros. Eros was erotic beauty, and Psyche was the inner soul beauty. So we really have this original soul that even the etymology goes back further to the word breath. So we have the word, the study of the soul, or the study of life itself, is the earliest etymological definition of psyche. In the 1600s, around 1650, psyche changes. It's changed meaning to avoid the metaphysical, the religious aspects, and it's turned from soul to mind. So when you read Plato, when you read The Republic, and he's talking about the psyche, it's actually translated usually to soul. If you replace that word soul with the word mind, you'll be able to understand this as a contemporary, reading a contemporary psychology book. So we always want to understand how the etymology and the historical context of the definition of the word, so as we do with science. So we're talking now here about modern period science from the Enlightenment tradition. So roughly 1650, things didn't suddenly change in 1650. But we use this as just a rough guidepost to mark when modernism begins. So early 1600s to mid 1600s, the word science begins to change to something that we understand it to be today, a method that goes towards some sort of factual knowledge. Science assumes that what is being investigated is lawful. So in other words, one of the rules of science is that you should be able to predict and control by cause and effect relationships. This is lawfulness. So lawful means that has regular repeating relationships. Now, it should be realized at this point that we have no laws in psychology. Of course, neurons may behave at a chemical level or at a cellular level in some sort of lawful way. And some would argue that that's biology and not psychology. But in psychology itself, we have no laws. We found that this became exhausted by the behaviorists. This concept was exhausted most recently by the behaviorists, but their SR psychology, stimulus response psychology. And of course, what comes between the stimulus and response is the organism. And this organism is a filter. The organism makes decisions. So in the human condition, we have no laws. We have no laws in psychology. This has been a criticism by the human sciences, the humanities, as we can call them, that psychology is not a science, and because there is no lawful behavior in the human being. So this is a criticism that we take seriously, and we understand that these 7 schools of thought of psychology can find themselves either in the natural science perspective or in the human science perspective. So cognitive psychology and behaviorism and biological psychology, evolutionary psychology, all align themselves with what we call natural sciences. And humanism And psychodynamic psychology and existential phenomenological psychology ally themselves with the humanities, what we call the human sciences. They have different definitions, different goals, and different beliefs of how and what psychology does. So there are two kinds of laws. We have correlational laws and we have causal laws. Causal law is how X causes Y. And a correlation laws is some sort of lawful behavior of how things exist and relate to one another. And of course, we don't have scientific laws in psychology. We have general tendencies in psychology. Scientists have, because of lawfulness, there's an assumption of determinism, and determinism is the assumption that what is being studied is lawful. So we have an interesting phenomena that occurs in psychology where we have some that fall in the camp of biological determinism, the idea that genes or brain chemicals or brain structures cause behavior or cause personality. And we have what we call environmental determinism, such as social psychology, which looks at how the environment determines individuals' personality or thinking. And there was a time period when when people were unapologetically proposed themselves to be part of one camp or the other. We call this nature, nurture, etc. But today we have a little less of the bandstanding with this and more of what we call a interactionist model. And we'll hear things such as a 60-40, 60% biological, 40% genetic. And there are different methods that attempt to arrive at these conclusions, which we're going to look at in this course and critique those as well. So determinism is a big part of psychology being a science. Now, you've heard of humanism and the existential phenomenological psychologists. Well, these two groups feel that that determinism is not the only answer. So in other words, we sometimes think that environmental determinism is somehow liberal and biological is somehow conservative. So one is saying that we're determined by our genes or our chemicals. The other is saying we're determined by our environment. The humanists say we're not determined at all. We have free will. Now, most of us believe in free will, that choice is a part of this. And cognitive psychology actually studies choice, as does behavioral economics in psychology. However, the idea of free will is not congruent with science. In other words, a lawful science has no free will. And that's something to really chew on and think about. And if you want to look into it further, there are volumes of philosophy books, philosophy of science books that discuss this. So for everything that ever happens, there are conditions such that given them, nothing else could happen. That's in the dictionary, Encyclopedia of Philosophy Dictionary definition of determinism. Mechanism. This is one of the assumptions of biological psychology, and it's the idea that variables function together in a cause and effect chains that fit together as a whole. So when you hear things about mapping the neurons of the brain or mapping the brain, that is an assumption of mechanism. This is an old Newtonian physics, classical mechanics, early view of what science is and how it functions. And this really was the worldview until 1905 when we had the Einsteinian revolution, quantum mechanics, and we found that that things don't interact in this mechanistic, materialistic way. The assumption of reductionism. This is the idea that smaller causes larger, that in order to get to something, we just dissect it more down to the tissue level or the neural level, the chemical level, the cellular level, the atomic level, the subatomic level. And to just illustrate the why this is a fallacy, smaller causing larger would be like if we go to Google Maps, and this is the analogy that I developed to explain this. When we have the zoom out view, we have the social world. We may even have groups of people. And as we zoom in, we get down to the individual personal level, and then to the brain level, and then down to the neural level. But this would be, to say that the neurons cause this behavior, this group interaction, would be like saying oh, I don't know if this is the city of Newark, and this is zoomed down to an individual, or a certain street or a certain block or house in Newark. It would be like saying that house causes, or these collection of houses cause the city to exist. And that, of course, is a very kind of bizarre way of thinking about things. When we talk about this as far as neural or chemical levels and social levels, we often accept it. Of course, when we talk about this as a psychological phenomenon, we accept this. We don't question that the idea that this social phenomenon of love is a result of oxytocin. These models somehow captivate us, and they are based on a reductionistic assumption, a fallacy. The relationship between group and cellular is not a causal relationship. It's a relationship of level. And what I mean by a relationship of level is this. We can understand this phenomena of the social level as being a certain, looking at it from the social level, we zoom in with the microscope and then look at it the personal level, and then at the cell, at the biological, the tissue level, and then the cellular level, and then the subatomic level. One's not causing the other. They're different. There are different points of view of the same phenomena. Person doesn't change in how we understand them to be a person based on how close we're standing to them. So we want to remember this is a correlation, not a causal relationship. Here are some famous philosophers of science. These are, I would say, go out and buy these books. Popper's The Logic of Scientific Discovery, Thomas Kuhn, The Structure of Scientific Revolution. There is in particular a series of lectures on science and the philosophy of science that I would encourage everyone to look into. And as I pull these off of my bookshelf to read them to you, these are provided by the Great Courses, which the teaching company online, and this are presented by Professor Stephen Goldman from Lehigh University, and they're called The Science Wars. And if you get this collection of lectures, this is a great way to study the philosophy of science. Also a book called Worldviews by DeWitt, D-E-W-I-T-T. Both of these will go into depth and teach you the history of science, and this is a philosophy of science and the wars of philosophy of science wars that exist. Well, two of the major players are Thomas Kuhn and Karl Popper. Now I have a link here to a video that you can find on Google. It's an interview between Brian McGee and Hilary Putnam, who is a very famous philosopher of science from Harvard University. And I'm going to include this link for you to understand. This is a great introduction to the history of science and the philosophy of science. So I want to take a moment to explain the Kuhnian, these two books, Structure of Scientific Revolutions by Thomas Kuhn, and Karl Popper's The Logic of Scientific Discovery. So to offer a brief overview, and again, we'll be going more into, you can learn more about this in the Putnam video, as well as the DeWitt Worldviews and the lectures on the science wars. But in a nutshell, Karl Popper's point of view on science. Firstly, science does not start with observation. It starts with a problem and then tries to find solutions to the problem. And then it tries to find faults with the solution. This is what we call falsifiability. In order for something to be scientific, Popper said it has to be falsifiable. So this is in line with the logical, avoiding the logical fallacy of moving the goalposts. So sometimes you'll have explanations that no matter what the evidence says to the contrary, it can be made to fit the theory. This Popper says cannot be a part of science. Science has to, in other words, a hypothesis has to be able to be proved incorrect. And he also said that we should be looking to disprove theories, not prove them. So when we do that research method section of research, so we have a hypothesis, the research, and then the theory. In that hypothesis, we shouldn't be looking for supporting evidence. We shouldn't be looking for evidence that supports our hypothesis. We should be looking for evidence that disproves our hypothesis. So he said that science comes in 3 stages. You have a problem, you have a theory, and you find criticism of the theory. Popper described something called post-diction, which is explaining something after it happens, and he said that's not science. So for Popper, science had to make the prediction before it happened, not explain it after it happened. And he felt that science must continue to be wrong and always become better. So you never had a big T truth with Popper's view of science. You never arrived at facts. You just had current probabilities. And Popper was an individual who loved to criticize Freud and Adler and psychodynamic theory. Thomas Kuhn. Now, Thomas Kuhn is the theorist of science who greatly disagreed with Popper. And he is also the individual whom we are using to structure how we understand our history of psychology. So it's important that you understand that Thomas Kuhn's book, The Structure of Scientific Revolutions, is greatly rooted in that Hegelian dialectic that I taught earlier in this lecture. So Kuhn looked at science very differently. He said science is he said that science is not a steady progressive, and it's not steady, it's not progressive, and it's not objective. And he argued about the idea of big T truths. He even dismissed the idea or challenged the idea that there was this independent objective world that science can get at. And Kuhn showed us that science was a subjective and socially determined act. Now, there's a lot going on here. And so I want to tell you, Kuhn is greatly rooted in French rationalism and German idealism, which challenged these Popperian ideas of objectivism and empiricism. These are all words that are going to make better sense as the course goes on. And he felt that science was almost like a popularity contest. In other words, what science was at any point in history, what the definition of it was and how it was done was largely determined by political, economic, and social factors. So he talked of things called paradigms. And a paradigm, this is what we're looking at our history as a paradigmatic dialectic. So a paradigm of psychology would be like the 7 schools of thought, but the paradigm is can become normal. In other words, a paradigm of psychology, something is pre-scientific, and then when most of the people or all of the people within that field begin following the same rules and agreeing to the same definitions and the same methods, it then becomes a normal science. And then that normal science fractions off into disagreements, and a revolution takes place, and then there's a new normal science. So science in it's how it's done and whatnot continuously changes. We see this in the history of the natural sciences, something physics. Newtonian classical mechanics was revolutionized and dismissed in 1905 as for quantum mechanics, and there's been the Einsteinian revolution, and then we have string theory and chaos theory that compete today, theoretical physics, etc. So the way physics is done at the atomic level is not compatible with the way physics is done at the classical mechanics level of Newton. Interestingly enough, as you'll see in this lecture and the upcoming lecture, much of what experimental psychologists think science is really an antiquated Newtonian classical view of science that is no longer used in science. So there are things that are done in physics that in the science of physics and biology and chemistry that would never be allowed in psychology. And there are reasons why this has happened. Largely it's because many people psychologists don't study the philosophy of science or even study the history of psychology, or the history of science, so they don't maybe understand that the model with which they're basing their research on is antiquated. It's a Newtonian view. For example, most research professors would never allow their students to do thought experiments as a dissertation. However, all of Einstein's experiments were thought experiments. He never conducted an experiment. They were all thought experiments. If you read his general and specific theories of relativity, you'll find thought experiments. So this is an example of how the other sciences have moved away from this Newtonian rigidity, and psychology, for the most part, remains in it. Much of the schools of scientific psychology. So Kuhn said that a normal science is, in other words, the when everybody agrees how it should be done. He said that normal science turns into this problem-solving expedition, finding problems within a context and then solving those problems. And we have the pre-paradigmatic stage. That's the state of, say, psychology before there was a unified way of looking at it, and then one unified way of looking at it, and then the revolution. And we see these paradigms existing from behaviorism to cognitive, some would argue. The behavioral paradigm, there was a revolution, there was the cognitive revolution, and we had the cognitive paradigm. So the paradigm, the entire constellation of beliefs, values, techniques, and so on shared by the members of a given scientific community. That's what a paradigm is. These are concepts that we have just discussed. So an important aspect here that Kuhn points out down here, the paradigm predetermines what the answers can be. So if you are asking, you're doing research within a cognitive school of thought paradigm, it's going to limit what kind of answers are possible. If you're exploring something from the behaviorist paradigm, from that theoretical framework, you're limited to a certain type of answer. Psychoanalysis, psychodynamic schools of thought will limit the answers that we can come up with. And this is very important to remember, and Paul Feyerabend pointed this out, that the more rules we have, we become more certain about the things that we study, and the results we have become less important, less consequential. So Kuhn pointed out that there's usually a great resistance to a new paradigm. Evidence seldom changes, but the culture and politics do. Followers of the old paradigm retire, and new generations brings with it a new paradigm. The science is a social, economic, and political phenomenon, not a singular method. So science for Kuhn is culture, personality of the scientist, politics, economics, methods that are in vogue. And these are the stages Kuhn said each paradigm goes through in science. So here are the 7 schools of thought in psychology. Some of these were major paradigms, some were not. So behaviorism, biological, cognitive, these were evolutionary. These were all major paradigms. Humanist, existential, phenomenological, psychodynamic. Psychodynamic was definitely a major paradigm for clinical work. But humanism and existential phenomenology have never been dominant paradigms. Sociocultural, well, it's been pointed out by more than one author that social psychology is often tacked on to as the last chapter in a psychology, introduction to psychology textbook. It says, oh yeah, and then there are these guys, these guys and girls who they do this thing, and there some psychologists, labs style psychologists, hold social psychologists in contempt. So this is interesting how this functions, and each of these schools of thought has its own definition, its own methodologies, its own ways of doing psychology, and who is right depends on whom you choose to follow. This is a model that I came up with to illustrate something we discussed earlier. I call it the macro and micro level of psychology. It's an inverted pyramid. And we say the big picture, I claim the big picture, if we were organizing an introduction to psychology textbook, and actually years ago I taught Intro to Psych, and I used to teach it in this order. I didn't start with biological psychology, I started with social psychology. Because this was most relevant to students. Students wanted to understand social interactions. So right off the bat, we're starting with social interactions. And then we zoomed in a little bit and looked at personality. And then we zoomed in a little bit more and looked at abnormal personality. and what that even means, abnormal versus normal. We then looked in at motivation and emotion, the specifics about the person, and learning and language and thinking, and then consciousness. Then we got down to the sensation and perception. Each of these are chapters in an intro book. And then finally down at the micro level to biological. So again, we're not looking at one causing another. We're looking at different levels of the same phenomenon. We talk about philosophical theoretical psychology and experimental scientific psychology. The critical psychology, history of psychology book that I recommended to you by Walsh, Teo, and Bedala. They describe this as naturalistic science or natural science and human science. We might call this the humanities and the natural sciences. Well, if we look at this, the philosophical traditions, so humanism, existential psychology, psychodynamic, these are strongly rooted in philosophical, non-scientific philosophical, non-natural philosophical ways of doing science. At the other end, we have the neuroscience and the biological psychologists, cognitive psychologists and the behaviorists, and then they're very much based in natural sciences, and then also the evolutionary psychologists, and then here this social psychologist, we get a mixture of natural scientists and philosophical scientists. But here we want to keep in mind there's psychodynamic social psychology and there's biological social psychology. Evolutionary psychologists, I put them in the middle. They are natural scientists, of course, but you're going to find something interesting with evolutionary psychology. They often discuss humanism and existentialism and phenomenology and psychodynamic discussions. They're all discussed. So evolutionary psychologists have an interesting freedom to not be as rigid with being seen as scientists, perhaps. Here are some of the big philosophical issues: determinism, indeterminism, and non-determinism. We're going to look at those philosophical concepts: biology and environment, nativism and empiricism. You also know this is nature and nurture, or nurture and nature. Mind-body problem, rationalism, irrationalism, humans and non-humans, origins of knowledge, objective and subjective reality, the self, universalism, and relativism. These are all concepts that we discuss in philosophy of science. So as we said earlier, what's determinism? Determinism means everything is caused. You have biological determinism. These folks say it's genes or brain chemicals. You have environmental determinism. These folks say it has to do with your education and the parenting styles and socio and economic stuff. Sociocultural determinism is, again, economic class, social class, which side of the tracks one grew up on. But these are all deterministic. Physical determinism is genes, and psychical determinism is cultural rules and thinking and experience. Now, indeterminism is based on Heisenberg's uncertainty principle, and this has been influenced by theoretical physics. And this says things can be determined but not measured in any way. The act of observing changes the thing. It's like German idealism. We participate in the event that's happening. So the moment that we observe it, we influence it. And non-determinism, this is the humanist idea that there's free will and choice, and science cannot be used to study the human condition. I like William James, America's father of psychology. William James, Harvard University, founder of their psych department on determinism. 1890, he wrote a book called The Principles of Psychology, 2-volume massive text that resides on the bookshelf next to my desk, and I always consult what James had to say. He says soft determinism are intentions, motives, and beliefs that influence habits, and hard determinism are what we call hardwired reflexes. So James, back in 1890, said there is hard determinism. There are things about the human condition that we are biologically chained to. He said, but there's also soft determinism. And soft determinism has a lot to do with what we've learned in our decision-making and the skills for decisions we have. And this is a model that I find very convincing, and I think it would be good for us to resurrect this way of thinking of soft determinism rather than hard determinism. I just want to give you an example. This was put forth by a theorist named Erich Fromm. he pointed out that in his book, The Heart of Man, that the decision to have the affair doesn't happen when two people are naked together in bed. The decision to have the affair happens when one of the individuals accepts the drink after work. So he said that in the beginning, we have much more freedom to say no than we have as we move along the chain of events that occur. This is an interesting way of thinking about this. The mind-body question. Well, we have materialists, we have idealists, and we have dualists. The materialists say the mind and body is all one thing. They're monists, that the mind is a consequence of biological physical processes. There aren't separate soul and body or mind and body. The dualists say that mind and matter are two different things, that there's a soul, that the ghost in the machine. This is Rene Descartes in rationalism, the idea that there's a mind and a body and that they're related in interesting ways, but they're separate. The idealists, this is all ideas. The mind and body are ideas that we come to understand things through. And so this is really German idealists are the most philosophical of the scientists, and we find them in existential phenomenology and humanism. We're going to be getting into those in depth. So I know this is a kind of like a thumbnail sketch of each of these, but this is what we'll be studying in this course. And right now I just want you to know that the three different exists: materialists, idealists, and dualists. We're also going to see materialists. We call these the British empiricists. These are the folks who believe that it's an objective, measurable, and observable scientific methodology that comes to measurable truths. The dualists are French rationalists who claim that reality isn't out there. Reality is a cognitive filter, a perceptual event of things out there. The idealists say there's no out there, that this is a reciprocal, that we are responsible for bringing about reality in a psychological way. Okay, that's a bit much to chew on, so let's unpack that later. So there are different types of dualism. We have interactionism, emergentism, epiphenomenalism, psychophysical parallelism, double aspectism, occasionalism. Occasionalism is this idea that there was a pre-established harmony between mind and body. This was put forth by certain philosophers. Double aspectism is the idea that that the mind and brain are two sides of the same coin, but they're not separate. This is very popular today. Psychophysical parallelism means environment causes physical and mental responses independent of each other. Epiphenomenalism is another one that has been popular today. The brain causes mental events, but mental events do not cause behavior. Mind is a side effect. This is very popular in neuroscience and evolutionary psych. Emergentism, another big one for cognitive and evolutionary psych, thinking and emotion emerges from brain states and then influences the brain states, a feedback feed-forward loop. And interactionism, mind and body influence each other. We know William James said about this, of course, that we think that our heart beats faster because we're scared, but he said that our heart first has the physiological beating faster than we interpret that as fear. I like to propose the idea of theoretical physics, the Mobius strip. I first spoke about this in a book that was published in 2010 called A Post-Cognitive Negation, the Sadomasochistic Dialectic of American Psychology. In that book, I pointed out that we had proposed a new model for understanding the nature and nurture debate, or the mind-body split, etc., and that it functions like a Mobius strip. And the Mobius band or the Mobius strip, of course, the more you try to separate these two, they become more and more entwined. Rationalism is, just wanted to mention, if you want to understand this Mobius strip better, you can take a piece of paper, put a half twist in it and tape it, write nature on one side, nurture on the other, and then cut down the center, and you'll find that it just keeps exponentially replicating itself. It never separates out. So this idea here is that for 3,000 years we've been trying to separate nature from nurture with twin studies, etc., and it's failed. We've not been able to do this. And my proposal here is we're asking the wrong question. So what is rationalism versus irrationalism? Well, rationalism, now this is different than French rationalism. The French rationalists that we spoke about earlier, this is a task in philosophy to understand what words mean within their given context. So when we talk about French rationalism, this is the idea that we have perceptions of we have subjective perceptions of objectivity. This kind of rationalism is kind of the emphasis on logic and systematic thought. Irrationalism is this focus on the unconscious and on emotions. So as Blaise Pascal said, the philosopher Blaise Pascal, the heart has its reasons that reason knows nothing of. This is, if you're a Freudian, if you're a psychoanalyst, you believe that the irrational leads the way. Most cognitive psychologists and behavioral economists and behaviorists behaviorists do not talk about rationalism, but economic behaviorists talk about rationalism, like logic and systematic thought. Just to point out, I unintentionally said behaviorist in isolation. They had no use for the idea of thinking. They called it the black box. So definitely would not have been behaviorists. So universalism and relativism. Universalists say there are big T truths. These are almost like religious folks who say that we come to big T ultimate truths, and relativists say we have contextual little t truths. This coming from the tradition of Friedrich Nietzsche. The idea of objectivity and subjectivity, naive realism. This would be objectivism, the British empiricists, what we experience is real. Reification is a concept that talking about something makes it real. So, for example, the word trait. Sometimes students speak of and think of traits as something that floats around in chromosomes or in genes or in the bloodstream. The word trait is another word for the word adjective. It's a descriptive word developed by Gordon Allport. We have used the term trait so frequently that it's become a real substance. It's become reified, in other words. The subject-object split is the concept that subjectivity, we have an individual who can be the object of its own subjectivity, and this is what happens when we recognize ourselves in the mirror for the first time as infants. At this moment, there's a subject-object split. This is what Jacques Lacan, French psychoanalyst, described. Subject-object split occurs, and this is the moment that we become aware of ourselves. We have a subjective experience of our objective self. We have being with a small b as an existence, and being with a big B as existing in space and time. Or we can say it the opposite. Being with a big B is the existential subjective, and being with a little b is a physical being. Just more commonly discussed that way. We have different philosophical schools of thought that go subject-object split is definitely a part of German idealism and French rationalism. Naive realism is definitely part of the British empiricism. As we're going to learn, British empiricists often stress objective scientific psychology as an objective scientific endeavor, whereas the German idealists use models that are more based on, say, theoretical physics and philosophy. I like to show this little clip from Alan Watts, which was animated by Trey Parker and Matt Stone from South Park. And I think it really gets to, when we're talking about these debates of nature and nurture and mind and body, etc. I think Alan Watts, the Buddhist comparative theologian, really hits at something here. So we'll watch this together.
You see, in the history of philosophy and poetry and art, we always find the interchange of two personality types, which I call prickles and goo. The prickly people are advocates of intellectual porcupinism. They want a rigor. They want precise statistics. And they have a certain clipped attitude in their voices. And you know this very well in academic circles, where there are people who are always edgy like that. And they accuse other people of being disgustingly vague and miasmic and mystical. But the vague, miasmic and mystical people accuse the prickly people of being mere skeletons with no flesh on their bones. And they say to you, you just rattle. You're not really a human being. You know the words, but you don't know the music. And so therefore, if you belong to the prickly type, you hope that the ultimate constituent of matter is particles. If you belong to the gooey type, you hope it's waves. If you are prickly, you're a classicist. And if you're gooey, you're a romanticist. And going back into medieval philosophy, if you're prickly, you're a nominalist. If you're gooey, you're a realist. But we know very well that this natural universe is neither prickles nor goo exclusively. It's gooey prickles and prickly goo. And you see, it all depends on your level of magnification. If you've got your magnification on something so that the focus is clear, you've got a prickly point of view. You've got structure, shape, clearly outlined, sharply defined. When you look out of focus, it's going to go bleh, and you've got goo. But we're always playing with the two.
So now we will turn to the Hilary Putnam and Brian McGee video on the history of science, and this is essential viewing. I show it in all my classes, and we have in-depth analysis of this. So make sure you don't skip it.
The connection between philosophy and the mathematical sciences has always been very close. Plato had written over the door of his academy the words, "Let no one enter here who is ignorant of geometry." It was Aristotle who codified the basic sciences into the categories and gave them the names that we use to this day. Some of the greatest philosophers have been themselves great mathematicians who invented new branches of mathematics. Descartes is an obvious example, and so is Leibniz and Pascal. In fact, most of the great philosophers, not all, but most, came to philosophy from mathematics or the sciences, and this tendency has continued into our present century. Bertrand Russell was trained first as a mathematician. Wittgenstein was trained first as an engineer. The reason for this persisting connection is, I think, obvious, and that is that the basic urge which has driven most of the greatest philosophers has been the urge to deepen our understanding of the world and of its structure, and this is also what creative scientists are doing. For most of the past, too, people thought that mathematics was the most indubitable knowledge, as well as being utterly precise and clear, that human beings possessed. So there have always been plenty of philosophers examining mathematics to try and find out what was so special about it, and whether this was something that could be applied to the acquisition of other sorts of knowledge. Ditto with the sciences, which were also thought to yield a very specially safe and certain kind of knowledge. What was it about science that made its results so reliable, people asked themselves, and could its methods, whatever these were, be used in other fields? These investigations into the concepts and methods and procedures and models that are involved in mathematics and in science have come to be known as the philosophy of mathematics and the philosophy of science. And it's with these that we're going to be concerned in this program, chiefly with the philosophy of science, though in fact we have someone taking part who is expert in both, Professor Hilary Putnam of Harvard University. Professor Putnam, I'd like to start our discussion from a standpoint which I think a very large number of our viewers occupy anyway. And it's really this. Since the 17th century, I suppose, there's been a spectacular decline in religious belief, especially in the West and especially among educated people. And for millions, the role that used to be taken in life by a worldview based on religion has been increasingly supplanted by a worldview based on science, or at least purporting to be derived from science anyway. And this is still enormously powerful in the hold that it has on people's minds throughout the West. Probably it affects all of us. So I think I'd like to start this discussion by getting you to pin down that scientific world outlook which is so influential in the modern world and which will be underlying a lot of what we're going to have to talk about.
Let me dodge the question a little bit by talking not about what scientists think now, but what many scientists thought 100 years ago or 75 years ago. Think of doing a crossword puzzle. You might have to change a few things as you go along, but towards the end, everything fits and things get added on one step at a time. That's the way the progress of science looked for 300 years. In 1900, a famous mathematician, David Hilbert, gave a list of 50 mathematical problems to a World Congress of Mathematicians, which are still very famous. And it's very interesting that he included one problem which we would not call a mathematical problem very early in the list. I think it's problem 3, which was to put the foundations of physics on a satisfactory basis.
Just a small task. And that was for mathematicians.
That was for
not
mathematicians,
physicists.
not for physicists.
Yes,
Right.
yes.
The idea is
Just to tidy it up.
That's right.
Yes.
The idea is Newton, Maxwell, Dalton, and so on had all put in all the parts of the story, and now it was just for mathematicians to basically clean up the logic, as it were. I think in a conversation we had a couple of days ago, you described this as a treasure chest view, and I like that picture. Because here's this big chest that we're just filling up. It's an accumulation, and you don't have to subtract, you don't have to take out. Occasionally you make a little mistake, but basically the idea is, or to shift the metaphor, like building a pyramid. You put down the ground floor, then the next floor, then the next floor, and it just goes up. That's part of it, this view of knowledge as growing by accumulation. The other part of it is the idea that the special success of the sciences, and obviously what we're impressed by is success. This culture values success, and science is a successful institution. But there's the idea that science owes its success to using a special method. And that comes partly from the history of science, from the fact that Newton, for example, lived after Bacon and was influenced by Bacon, and the idea that empirical science has grown up together with something called inductive logic. And this idea that there's a method, the inductive method, and that the sciences can be characterized by the fact that they use this method and use it explicitly and consciously, as it were. Not unconsciously, as maybe someone who's learning cooking might be using it, but pretty deliberately and explicitly. So I think that these two things, the idea of knowledge is growing by accumulation and growing by the use of a special method, the inductive method, are the key elements of the old view.
Yes, and if I were going to put the same thing, I suppose slightly differently, I think I'd say this, that for 200 or 300 years, educated Western man thought of the universe and everything in it as consisting of matter in motion. And that was all there was, whether from the outermost galaxies of the stars into ourselves and our bodies and the cells of which we're made up and so on. And that science was finding out more and more about this matter and its structure and its motion by a method which you just characterized as scientific method. And the idea was that if we went on long enough, we'd simply, as you said with your crossword puzzle metaphor, we'd find out everything there was to find out. We could eventually, by scientific methods, completely explain and understand the world. Now, that has been abandoned by scientists, hasn't it? Though, in fact, this hasn't got through yet to the non-scientists. There are still large numbers of non-scientists who go on thinking that that's how scientists think. But, of course, they no longer do they? I mean, this has started to break down.
I think it started to break down. I think it started to break down with Einstein.
Yes.
If I can drag in a bit of history philosophy, screaming by the hair, Kant did something in philosophy, which I think has begun to happen now in science. He challenged a certain view of truth. Before Kant, no philosopher really doubted that truth was simply correspondence to reality. I mean, there are different words. Some philosophers spoke of agreement. But the idea is a mirror theory of knowledge. Today, I think, Kant said it isn't so simple. There's a contribution of the thinking mind. Sure, it isn't made up by the mind. Kant was no idealist. It isn't all a fiction. It isn't something we make up. But it isn't just a copy either. What we call truth depends both on what there is, on the way things are, and on the contribution of the thinker, the mind. I think that today scientists have come to a somewhat similar view. That is, since the beginning of the 20th century, the idea that there's a human contribution, a mental contribution, to what we call truth. The theories aren't simply dictated to us by the facts, as it were.
I'd like to ask you to unpack that a little, because I think that some of our viewers will find this idea a little puzzling. How can it be, some people will ask themselves, that what is and is not true can depend not only on what the facts are, but on the human mind? How can that be?
Well, let me use an analogy with vision. We tend to think that what we see just depends on what's out there. But the more one studies vision, either as a scientist or as a painter, one discovers that what's called vision involves an enormous amount of interpretation. The color we see as red is not the same color in terms of wavelengths at different times of the day. So that even in what we think of as our simplest transaction with the world, just looking at it, we are interpreting,
In other words, we bring a whole number of things to the world that we're not directly conscious of, usually, unless we turn inwards and start examining them.
That's right. I think the world must have looked different in the Middle Ages to someone who looked up and thought of the stars as up and us at the bottom, for example. Today, when we look out into space, I think we have a different experience than somebody with the medieval worldview.
And what you're saying is that the very categories in which we see the world and interpret our experience, and the ideas within which we organize our observations and the facts around us and so on, are provided by us, so that the world as conceived by science is partly contributed by external facts, but also partly contributed by categories and ways of seeing things which come from the human observer.
That's right. And an example of that in science, I'll oversimplify, but it's not basically falsified, is this wave-particle business. It's not that there's something, an electron, which is half a wave and half a particle. That would be meaningless. But that there are many experiments which can be described two ways. You can either think of the electron as a wave, or you can think of it as a particle, and both descriptions are in some crazy way true and adequate.
There are alternative ways of describing the same facts, and both descriptions are accurate.
That's right. Philosophers have started talking of equivalent descriptions. There's a term used in philosophy of science.
But now, for a couple of hundred years after Newton, educated Western man thought that what Newton had produced was objective fact, that he had discovered laws which governed the workings of the world and the workings of the universe, and this was just objectively true independently of us, that Newton and other scientists had read these facts off of nature by observing it and looking at it and so on. And these statements which made up science were simply true. Now, didn't there, a period in the development of science, beginning in the late 19th century, when people began to realize that these statements were not entirely true, that this wasn't just a body of objective fact which had been read off from the world. In other words, that science was corrigible, scientific theories could be wrong. And that raises some very profound questions. I mean, if science isn't just an objectively true description of the way things are, what is it? And if we don't get it from observing the world, where do we get it from?
Well, I don't want to say we don't get it from observing the world at all. Obviously, part of this Kantian image is that there is a contribution which is not us, there's something out there, but that also there's a contribution from us. And even Kant, by the way, thought that Newtonian science was indubitable. In fact, he thought we contributed its indubitability. The step beyond Kant is the idea that not only is reality partly mind-dependent, but that there are alternatives, and that the concepts we impose on the world may not be the right ones, and we may have to change them, that there's an interaction between what we contribute and what we find out.
Now, what was it that made people begin to realize that this basic conception of science as objective truth was wrong, that science was corrigible, that science was fallible?
I think it's that the older science turned out to be wrong where no one expected it to be wrong, not in detail, but in the big picture. It's not that we find out that, say, the sun isn't 93 million miles from the Earth, but only 20 million miles from the Earth. That's not going to happen. I mean, sometimes it makes blunders, even about things like that, but that's like making a blunder about whether there's a chair in the room. Wholesale skepticism about whether numerical values are right in science would be as unjustified as wholesale skepticism about anything. But where the newer theories don't agree with Newton is not over the approximate truth of the mathematical expressions in Newton's theory. Those are still perfectly good for calculation. It's over the big picture. We've replaced the picture of an absolute space and an absolute time by the picture of a four-dimensional space-time. We've replaced the picture of a Euclidean world by a picture of a world which obeys a geometry Euclid never dreamed of. We've swung back to the picture of the world as having a beginning in time, which is really a shocker. It's not even that things once refuted stay refuted forever.
Yes. So it means really that a whole conception of science has been superseded. Instead of thinking of science as a body of knowledge which is being added to all the time by further scientific work, that whole conception of science has been dispensed with, really, hasn't it? And we now think of it as a set of theories which are themselves constantly being replaced by better theories, by more accurate theories, by richer, more explanatory theories. And even the theories we now have, like those of Einstein and his successors, will probably be replaced in the course of time by other, better theories, by scientists yet unknown. Isn't that so?
That's exactly right. In fact, scientists themselves make this prediction. That is, that the main theories of the 20th century, relativity and quantum mechanics, will give way to some other theory which will interpret both of them, and so on forever.
Now, this raises a very fundamental question, namely the question, what is truth? I mean, when we say that this or that scientific statement is true, or this or that scientific theory is true, what in these newly understood circumstances of ours can we mean by truth?
There are still two views, as there have been since Kant. One is this old correspondence view still has its adherents. But I think the view that's coming in more and more is that one cannot make a total separation between what's true and what our standards of assertability are. That the way in which what I call, using the Kantian picture, the mind dependence of truth comes in, is the fact that what's true and what's false is in part a function of what our standards of truth and falsity are.
And that depends on our interests, and which again change over time, of course.
That's right.
I'd like you to say a little more about this question of truth, because this again, I think, is puzzling to the layman. I think that people who are not trained in science or philosophy are apt to think that there are a certain set of facts, and a true statement is a statement that accurately describes those facts. I'd like you to talk a little about some of the difficulties that are actually involved in this.
I think the biggest difficulty in science itself comes from the fact that even within one scientific theory, you often find different accounts can be given of so-called facts. This came in with the special theory of relativity, when it turned out that facts about simultaneity, whether two things happened at the same time, could be described differently by different observers. One could say Boy Scout A fired his starter's pistol before Boy Scout B. The other could say no, Boy Scout B fired his starter's pistol before Boy Scout A. And if the distance is sufficiently large, so that a light signal can't travel from one to the other without exceeding the speed of light, then it may be both descriptions are correct, both are admissible.
Of course, this leads to, profound conceptual difficulties in understanding some modern scientific theories, and this prompts the thought that a scientific theory can be useful and meaningful and can work, even if nobody really quite understands what it means. And this is the case with quantum mechanics, isn't it? I mean, nobody is really sure what quantum mechanics actually means, and yet it works.
That's right. And again, there I want to say one shouldn't push that too far, because I think we don't want to give up our standards of intelligibility altogether. We want to say quantum mechanics works, and the very fact that it works means that there's something fundamentally right about it. And with respect to its intelligibility, we're willing to say in part that may be that we have the wrong standards of intelligibility, that we have to change our intuitions. But in part, there are real paradoxes in the theory, and I think that more work has to be done to really get a satisfactory resolution of these paradoxes. Things are very ticklish now.
Yes. I think somebody hearing our discussion, and to whom perhaps some of these ideas are new, might find himself thinking, well, if all this is so, how is it that science works? If traditional scientific theories are breaking down, if science is turning out not to be a body of reliable, permanent, firm, objective knowledge, if a significant proportion of every scientific theory is subjective anyway, in the sense that it's contributed by the human mind, by the observer, by the scientist, how is it in these circumstances that we can actually build bridges, fly aeroplanes, make rockets go to the moon, and actually make all this soft, fuzzy, changing, partly subjective body of theory work for us? It must fit the world in some very basic way, in spite of everything that we've been saying.
That's true, but I think the contrast between being subjective and fitting the world isn't altogether right. I'm not saying that scientific knowledge is subjective or that anything goes. I say we're in the difficult position that we often are in life of thinking there is a difference between good and bad reasoning, but we don't have a mechanical rule. In everyday life, we use interest-loaded terms. We wouldn't say that there's a policeman on the corner if we didn't have a whole network of social institutions. Somebody coming from a primitive tribe which didn't have policemen might say there's a man in blue on the corner. But the fact that the notion of a policeman is shaped by our interest doesn't mean that it can't be objectively true that there's a policeman on the corner. Also, I think science works precisely because of this corrigibility in large part, as Professor Poppers pointed out. The difference between science and previous ways of trying to find out truth is in large part that scientists are willing to test their ideas because they don't regard them as infallible in a way that was known at the beginning and then in the success of Newtonian science somewhat forgotten. And we've had to be reminded again of what Bacon knew, that you have to put questions to nature and be willing to change your ideas if they don't work.
In some respects, the traditional opposition between science and religion has, the two parties have crossed places, haven't they? I mean, many religious people now believe they have certain knowledge about the world, that it was created by a God, that he made us in his own image, gave us immortal souls which will survive our death, and so on. Certain very fundamental propositions which they hold with absolute certainty. And it's the scientist who believes that everything is fallible, that the world is a mysterious place, that we'll never get to the end of the mystery of, and so on and so forth. Isn't there something in that?
It may be.
You say it may be.
Yes, I'm not sure.
You're not sure. Well, let's not pursue that. But one point I do want to take up with you, leaving even religion aside, is that now that science is seen in this entirely different way that you've been describing by virtually all scientists, doesn't it mean that the difference between science and non-science isn't what it was always thought of as being? In other words, since science is so subjective, indefinite, changing, and so on, it's no longer a clearly cut and different kind of human activity or kind of human knowledge from other sorts of human knowledge and other sorts of human activity.
I think that's both true and culturally very important. I think the harm that the old picture of science does is that if there is this realm of absolute fact that scientists are gradually accumulating, then everything else appears somehow as non-knowledge, something to which even words like true and false can't properly apply. I think that the so-called fact-value dichotomy is a very good example of this. It's hard to have a discussion on politics, for example, without someone very quickly saying, at least in my country, is that a fact or a value judgment? As though it can't be a fact that Hitler was a bad man, for example, or a fact that Farrah Fawcett Majors is a beautiful woman.
And do you think that it is a fact that Hitler was a bad man?
Oh, yes, I do.
I do too, yes. But then if this is so, if we are abandoning so many of these comfortable, clear-cut distinctions of the past, what's the point of continuing to use the category or the notion or the term science anyway? I mean, does it any longer clearly demarcate something differentiable from everything else?
I don't think it does. I think that, if you're going to distinguish science from non-science, that makes a lot of sense if you still have this old view that there's this inductive method. What makes something science is that it uses it pretty consciously and pretty deliberately, and that what makes something non-science is either it uses it entirely unconsciously, as in learning how to cook, you're not consciously thinking about inductive logic, or perhaps doesn't use it at all, as metaphysics was alleged not to use it at all, I think unfairly. But once you say, but both say that there's a sharp line between, say, practical knowledge and science, and to say that the method which is supposed to draw this line is rather fuzzy, something that we can't state exactly, and attempts to state it, by the way, have been very much a failure still. Inductive logic cannot be, say, programmed on a computer the way deductive logic can be programmed on a computer. And I think the development of deductive logic in the last 100 years and the development of the computer have really brought home very dramatically just what a different state we are in with respect to proof in the mathematical sciences, which we can state rigorous canons for, and proof in what used to be called the inductive sciences, where we can state general maxims, but you really have to use intuition, general know-how, and so on in applying them.
One of the two categories that you described, the old-fashioned way of looking at science in terms of, was that there was a particular scientific method.
Yes.
That you observed the facts, and on the basis of these observed instances, you generalized to form scientific theories which you then verified by experiment and so on. That was the old view, wasn't it? Now that that has been abandoned, is there any longer any single method which is thought of as being scientific method?
I don't think there should be. People talk of scientific method as a sort of fiction, but I think that even in physics, where you do get experiments and tests which pretty much fit the textbooks, there's a great deal that doesn't and a great deal that shouldn't. And I think, in fact, in the culture, I don't really believe there's an agreement on what's a science and what isn't. Any university will tell you in its catalog that there are things called social sciences, that sociology is a science, that economics is a science. I bet if you ask anyone in the physics department whether sociology is a science, he'll say no.
And why will he say no? That's interesting.
I think the real reason is not that the sociologists don't use the inductive method. They probably use it more conscientiously, poor things, than the physicists do. I think it's because they're not as successful.
So in other words, science has become almost a name for successful pursuit of knowledge.
That's right.
Yeah. Well, now, I think you've given a very, very good description of the way in which this age-old view of what science was has broken down in our century and been replaced by something much more fluid and perhaps much more difficult to get hold of, but you have, I think, described it very clearly. Can we now come, against this background, to what philosophers of science are actually doing? You are a philosopher of science. What do you and your colleagues do?
Well, part of what we do, which I won't try to describe on this broadcast, is fairly technical investigation of specific scientific theories. We look at quantum mechanics very closely. We look at both to learn what lessons we can from it for philosophy and to see what contributions we can make as philosophers to clarifying its foundations. We look at relativity theory very closely. We look at Darwinian evolution very closely and so on. This is the part of philosophy of science that provides the data for the rest. But much philosophy of science shades over into general philosophy, and I think the best way to describe it is in terms of what we've been talking about. That is, each of the issues we've been talking about divides philosophers of science. There are philosophers of science who have a correspondence view of truth and try to show this can be made precise, that the objections can be overcome, you can still view science somehow in the old way, and there are others who try to sketch what another view of truth would come to. There are philosophers who still think there is an inductive method that can be rigorously stated and who work on inductive logic. And by the way, I think it's important that there should be, because we won't make progress to trying to state the inductive method if there aren't, and that there are others who view the development of science more culturally, more historically, and there are people like myself who have a sort of in-between position. I think there's something to the notion of a scientific method, there are clear examples, but that it's more or less a continuum, that you mustn't think of it as a kind of mechanical rule, an algorithm that you can apply to get scientific knowledge. So that I'd say each of these issues, the nature of truth, the nature of the scientific method, whether there's any necessary truth in science, anything conceptual contribution which is permanent and can't be subject to revision is a big question.
And who are you, plural, doing all this work for? I ask that. I don't ask that in an irreverent way, but what I have in mind is this. I've myself taken part in attempts to bring scientists and philosophers together for discussions of precisely the issues that you've raised. And these attempts have usually failed, and failed for the same reason, namely that the scientists lose interest. They go back to their laboratories and get on with doing more science, and the great bulk of working scientists, it seems to me, don't in fact take very much of an interest in the issues that you've been talking about. I think it's conspicuous that the greatest of all scientists are exceptions. I mean, the really blockbusting, the path-breaking scientists who've actually made the revolution in this century that you've been talking about, people like Einstein, Max Planck, Niels Bohr, Max Born, Schrödinger, de Broglie, these people were enormously interested in the conceptual questions that you raised. But these were the pioneering geniuses, and the great mass of thousands of scientists who follow on behind them and put their work to its practical application. They don't seem to care. So who is listening to you? Who is reading the stuff that you publish?
Well, I'd say, first of all, I think we are basically writing for the philosophically interested layman, for the reader of philosophy. I don't view philosophy of science as giving direct advice to scientists, just as I think moral philosophers are ill-advised to think that they're giving at least immediately current contemporary advice on how to live your life or what bills to pass in Parliament. On the other hand, I do think that scientists tend to know the philosophy of science of 50 years ago. And perhaps this is the bad thing, that is, perhaps this time lag, this culture lag, has some value in weeding out what they shouldn't pay attention to. I mean, it's annoying to a philosopher to encounter a scientist who's both sure that he needn't listen to any philosophy of science, and then who produces verbatim ideas which you can recognize as coming from what was popular in 1928.
And is there a direct parallel here between what you're saying about scientists and Keynes, the economist, Keynes's famous remark that nearly all businessmen who thought that they were indifferent to airy-fairy economic theory were in fact the slaves of the economic theorists of yesterday, of a previous generation?
That's exactly true.
I suppose another parallel one could make would be to say that the account that ordinary language users give of language and their use of language would be extremely unsophisticated, simply because they take it for granted and have never thought about it. That too would probably apply to the account that most scientists would give of what they were doing when they were doing their science.
That's right. That is, it's a mistake to think that merely because one practices an activity, one can give a theory of it.
One criticism that's often been made about philosophers of science is that although they talk of science in this general way, what they're nearly always referring to, in fact, is one science, namely physics. Now, it's true, isn't it, that the science in which the most exciting developments have probably taken place in the last 20 years, anyway, has been not physics, but biology. Our philosophers of science genuinely open to the criticism of being too physics-based in their view of science and having ignored biology too much.
I think I would defend us against that on the grounds that I don't, although the theories in biology are of great scientific importance, Darwin's theory of evolution, Crick Watson on DNA and so on, they don't by and large pose big methodological problems of a kind that don't arise in physical science. I mean, I'm not sure whether you're going to agree with that.
Well, I mean, you mentioned the word evolution just now, and it seems to me that here is a concept which originated in one of the sciences, namely biology, and which over a comparatively short period of time has spread throughout the whole of our culture, so that the way almost everybody thinks is influenced by the notion of evolution, not only about the origins of man, but about institutions or the arts or all kinds of other things. I mean, evolution has become a dimension of Western man's thinking about almost anything. Is that not so?
That's right. And perhaps there has not been enough attention to this theory, though what strikes me as interesting is that the possibility of explanations of what we think of as the biological kind, explanations in terms of function rather than in terms of the building, physics and chemistry, what you're made of, have come under more attention recently as a result of computer science.
Now this does raise something I'm particularly interested in when you talk of computer science, and that is the interaction between our technology, in the case of computers, and philosophy. Not just science and philosophy, but technology and philosophy. I mean, computers were originally constructed on the basis of a self-conscious analogy with the human mind, weren't they? But as they became more and more sophisticated, we began to learn things from them about the human mind. So our construction of computers and what they then tell us about ourselves seems to actually proceed by interactive growth. Isn't that so?
That's right. And today, this is one area, by the way, in which philosophers are in close contact with scientists. That is, the fields of linguistics, cognitive psychology, computer science, and philosophy of language today interact constantly. People send papers to one another, not because someone tells them to. There are conferences at which specialists in these fields meet together, again, not because someone decided there should be some cross-fertilization. The interesting thing about the computer case, if I can stick with it for a moment, is one might have thought that the rise of the computer, would encourage a certain kind of vulgar materialism. The idea, so after all, we are machines, so after all, everything about us can be explained in terms of physics and chemistry. Paradoxically, the real effect of the computer on psychology and on philosophy of mind has been a decrease in that kind of reductionism. See, the thing about the computer is that when you work with computers, you very rarely have to think about their physics and chemistry. There's a distinction that people draw between their software, meaning their program, their instructions, their rules, the way they do things, and their hardware. And generally you ignore their hardware. You talk about computers at the software level, and you wouldn't really be able to explain what they do in a way that would be of any use to anyone in terms of the hardware level. There is a kind of emergence here, although it's not a mystical kind of emergence. It's not that they're violating the laws of physics. It's just that the level of at higher level facts about organization have a kind of autonomy. You'd say the fact that it's following this program explains why it does this, and I don't need to know how it's built. I only need to know it can be built in such a way that it will follow this program. This is a return to a view if you apply this to the mind, it suggests a return to a view of the mind that I associate with Aristotle. There's the view that we are not ghosts in a machine, not spirits which only temporarily embodies, but that the relation between the mind and the body is a relation of function to what has that function. Aristotle said if you use the word soul in connection with an axe, and of course he said you don't, you'd say the soul of an axe is cutting. And he said the soul of the eye is seeing. And he thought of man as a thing that thinks.
Yes, you're talking now of the alternative to materialism and, say, a religious view that this gives us. Puts me in mind instantly of the most significant of all the materialist philosophers in the modern world, namely Marxism, which after all is the official state philosophy of about a third of mankind, as we sit here discussing this. Marxism claims to be scientific, and this is a very important thing about it. Is there a significant Marxist contribution to the philosophy of science?
I don't think there's a significant Marxist contribution, but I don't think that the Marxists were all wrong either. I think Engels was one of the most scientifically learned men of his century. He got a number of things wrong, but he had an immense general scientific knowledge. And Ante Düring, his big book on philosophy of science, although it contains some rather strange ideas, some of which he gets from Hegel, by the way, is on the whole a sensible book on philosophy of science, among other things. On the other hand, it's not specifically Marxist. I'd say that Engels' views in philosophy of science are in large part influenced by the standard philosophy of science of the time. They're a fairly sophisticated, inductive account.
And what about subsequent Marxist thinkers who also had some pretension to be philosophers, like Lenin, for example?
Well, I think they're uneven. Lenin, I think, is on the whole one of the worst. He says, for example, the theories are copies of motion. I mean, there you have the copy theory of science just copying off the reality in its crudest view. Mao is more sophisticated, but Mao is very influenced by John Dewey, who was widely read in China in the 1920s.
Do you think it's actually made a contribution to the subject as it is today, or not really?
I think that it anticipated, it perhaps might have made a contribution if people had been less ideologically divided, because I think non-Marxists could have learned. The Marxists were among the first people to try to somehow combine a realist view with a stress on practice, with a stress on corrigibility, and they were very hostile to the notion of a priori truth. And today, many mainline philosophers of science are very hostile to a priori truth. As it is, they play somewhat the role in philosophy of science, I think, that Keynes said they play in economics. He described Marx as one of his sort of underground predecessors.
Yes. When I was introducing this program, I mentioned not only the philosophy of science, but also the philosophy of mathematics. And before we close, I would like us to say something about that anyway. I suppose one can really say that the central problem in the philosophy of mathematics is a direct parallel to the central problem in the philosophy of science, namely, how does it fit the world? With science, it's how does science fit the world? In mathematics, it's how does mathematics fit the world? Is that right?
That's right, and it's even worse, because if you're trying to defend a copy view, a correspondence view of truth in empirical science, you can answer the question, well, how do we build up this picture in such a way that it corresponds? By saying we have sense organs. As I mentioned before, that's not a total answer because there's a tremendous amount of interpretation involved in simple seeing and simple hearing. But if you're talking about numbers and sets, and someone says, okay, if mathematical knowledge is simply some kind of a copy of the way numbers are and the way sets are and the way other abstract objects that mathematicians study are, the question then, what sense enables us to see how they are?
What is a number? Yes. A deeply problematic question, but still an important one.
That's right. And on the other hand, I don't want to say that the anti-correspondence view has it very easy either. It seems to me that mathematical knowledge is a real puzzle. And I think that philosophers should concentrate more on philosophy of mathematics than they do now, because it seems to be an area where no theory works very well.
Isn't there another very important parallel between mathematics and science? I mean, throughout the history of science, one of the conflicts has been between one camp who thought that it was all about objects in the world which existed independent of human experience, and another camp which thought, no, it's human beings and observers who actually contribute most of this. And as you pointed out much earlier in our discussion, the truth is almost certainly a combination of both. There is a long-standing dispute in mathematics, isn't there, between one body of people who think that mathematical knowledge is something that's, so to speak, inherent in the structure of the world, and we derive it from the world by experience and observation, and another body of mathematical thought that says, no, mathematics is a creation of the human mind, which we then try to impose on reality, like a grid, as it were, on a landscape. Isn't that so?
That's right. The latter story is attractive because of the sense organ problem, but it doesn't seem to work either because it seems that we're not free to impose any mathematics or any logic we want. Almost anyone would admit that at least you have to be consistent. And what's consistent and what isn't somehow something we can just make up or decide. As when we try to stress conventionalist accounts, subjective accounts, we come up against the objectivity of mathematics. When we try to stress the objectivity of mathematics, we come up against another set of problems. I think we can learn a lot more than we now know about human knowledge and about scientific knowledge by going further into this area.
Talking of where we're going from where we are, so to speak, I think the most interesting way in which you could end this discussion, Professor Putnam, would be by talking about what you regard as the most interesting problem areas of the moment, and therefore, I take it, the most likely growth areas for the immediate future in both of the subjects we've been discussing, philosophy of science and philosophy of mathematics.
Okay, I think that if I'm allowed to confine my prediction to the immediate future, because we know that long-run predictions are always false, but in the immediate future, I would expect philosophy of mathematics to be a growth area and philosophy of logic. I would expect philosophy of physics, I think, to decline somewhat from its central place in philosophy of science, although I think part of it touches philosophy of logic. The question, the astounding suggestion has actually come forward in connection with quantum mechanics, that we may have to change our logic, our view of what the true logical laws are, in order to really understand how the world can be quantum mechanical. And I think this side of philosophy of quantum mechanics, that touches philosophy of logic, will be a hot discussion area. But more generally, I think areas which we almost don't think of as philosophy of science that become philosophy of language and philosophy of mind, like these questions about computer models of the mind, computer models of language, and these more general questions about theories of truth, the nature of truth, the nature of verification, how science can be objective even though there's not a rigorous scientific method. I think these questions will continue to be the staples of the field.
One thing that worries me about this whole area is its relationship to the educated layman, I mean, which in a sense is the person our discussion has been for. After all, it's now over 70 years since the 25-year-old Einstein published the theory of relativity, and I'm sure you'll agree with me that it's true to say now that the great majority of educated people with higher educations, university degrees and so on, still have scarcely any idea of what this is all about, and it's done very little to actually influence their view of the world. Isn't there a danger that now science and mathematics are simply racing ahead, and the whole new range and world of insight that is giving us into the universe in which we live simply isn't filtering through to the non-specialist, or not filtering through anything like fast enough?
That is a danger, but it's one that something can be done about. There's now, for example, a text of special relativity called Space-Time Physics, which is designed for the first month of the first freshman college physics course. And the authors say at the beginning that they look forward to the time when it will be taught in high schools.
And do you think that time will in fact come, and quite soon?
I'm sure of it.
Yes, well, I think you're right, and indeed I hope you are. Thank you very much, Professor Putnam.
Thank you.